Welcome to Simulation Studio, Trnsys Simulation Studio. Trnsys Simulation Studio is a complete simulation package containing several tools, from simulation engine programs and graphical connection programs to plotting and spreadsheet software. It is an integrated tool which can be used from the design of a project to its simulation. In this module, you will be learning three things. 1. Trnsys requirements. 2. Introduction to Trnsys Simulation Studio interface. 3. How to create a new component in Trnsys. On the requirements of Trnsys, Trnsys Studio is a complete studio that yet requires other third-party softwares for various manipulations in a simulation project. The important third-party softwares to have are Visual Basic 2012 upward, 2. Intel Visual Fortran compiler specifically, and of course Trnsys Studio. Without this, it is impossible to create a functional component within Trnsys. Assuming that you have installed the software correctly, selecting Trnsys Simulation Studio in the Trnsys 15 folder of the Start button will launch the Simulation Studio software. For me, here is the shortcut to my Trnsys Studio on my desktop monitor, which I will launch right away. In general, the user will begin by making a new empty project from the File New menu in the main menu window menu bar, which creates a blank assembly panel window titled Project x.tpf. The user will then select components using the direct access menu, that is this one, direct access menu, one of the drop down main menus, and place the component on the assembly panel. Then using the right mouse button or menus, the user can then select and change the parameters and input values, etc. Delete, copy or paste the components, etc. Finally, the user can link these components together and connect the output of one component to the input of another component. The simulation can be executed once. All necessary components are placed in the assembly panel. The parameters and initial values are defined for each component. The necessary links between components are made, and the internal connections from one component output to another component's input are completed. The user will then select, calculate or press F8 in order to run the simulation. The results can be viewed and printed using the open menu on the Trnsys Studio. Based on these results, adjustments can be made to the components and the project in the assembly panel, and more simulations can be run. Alright, here is my Trnsys Simulation Studio window on the monitor. All of the main windows in the Simulation Studio program have some common properties. These common properties will be explained first before the presentation of each window. First, I'd like to talk about the main window. The main window is what users first see when entering the Simulation Studio program. As with other Microsoft Windows programs, it consists of a series of pull-down menus, several toolbars, and one or more active windows. On startup, the main window is empty. Normally, the assembly panel will be shown in the main window, and the user creates a new project or opens an existing project. Additionally, all other necessary features of Simulation Studio and other Trnsys tools can be accessed through the main window of Simulation Studio. Several of these features will launch separate programs which will open in their own windows depending on the current operation occurring. These windows are either usable or grayed out. The menus and sub-menus will be described further. So highlighted in red is the main window of Trnsys, which every user sees once you open the Trnsys simulation window. The second one is the assembly panel window. The assembly panel is the window in Simulation Studio where the user will create, modify, and run assemblies of models of projects. The assembly panel can be accessed by creating a new blank project, which we shall see later, or by opening an existing project using the file or open menu item. So the area highlighted in red, the gray area, is the assembly panel window. Number 3, we'll talk about the direct access toolbars or main menu. It contains all models available for creating projects. Models can be used by dragging and dropping into current project. This is a direct access toolbar for models or proformas or components within Trnsys. Both components are pre-installed and the ones that will be created by the user. These models can be used by drag and drop into current project, which we shall see later. Again, we also have the direct access toolbar. These are the tools for running simulation on Trnsys, which we shall explain them one after the other as we go further. And this is the direct access menu bar with all these components as it is with other Windows software. So all these are also available from the direct access menu, which appears when you want to run a project or when you're trying to create a project. Many of the windows in the Simulation Studio program contain toolboxes associated with the window. These toolboxes contain icons or tools which will launch various applications in the Simulation Studio program. Most of these tools, such as the Make Macro tool, work by selecting several items on the screen and then clicking on the icon or the tool with the mouse. The active tool is characterized in the Simulation Studio program appearing to be a depressed button, while the inactive tools appear to be extended buttons. So this is what you call the Make Macro or selection tool. Let me demonstrate to you how this will look like an active or inactive tool. You can see the tools are highlighted by virtue of the current operation within the assembly panel window. This tool appears to be depressed, the select tool, while others appear not to be depressed and some appear to be grayed out. So interactive tools. Alright, we'll go over to how to create a new component in Trnsys. Now that we're done with introduction to the Trnsys Studio interface. So for the creation of the new component, the Proforma is a standard method of documenting component models in Trnsys, and it has 4 tabs which we're going to look at right away. All components that are created or added to the Simulation Studio program have a completed Proforma in order to be used in a simulation project. The Proforma file has 4 tabbed panels containing all the information required to facilitate the transfer of knowledge related to the model and allowing the models to be used in the correct format. To get to the Proforma window, we go here either to New or you go to File, select New, and it brings us to New Component in Trnsys, where we have this here, creates an empty component, opens the Proforma editor to allow you to define the components variables. And then of course it gives you the option to also generate a source code, which can either be generated in Fortran code or C++ code, which allows you to write in your formula or equation into the component you have created for it to work based on your preferences. So after selecting new component Trnsys type, I can now click on create, and then a Proforma window opens up here on the assembly panel area. As you can see, there are 4 tabs on the Proforma which allows you to add value to these empty components. Without those values, this is just an empty component and cannot do very much in Trnsys. So whatever you fill in here will take a form or an identity of the model you're trying to build based on this input parameter. So we shall do this one after the other. On the general tab, we have object, a generic name describing the component model. For me, I'm going to create a component called CPC, or what I might call compound parabolic concentrator. And then the author, the name of the person who wrote the model. So I can as well put my name. Sorry. And the organization, the name of an organization with which the author is affiliated. So I can as well put the name of my organization, HACS, meaning Heritage Arts and Culture Services. Then the editor, often the person creating the simulation studio performer, is not usually the original author, and so the name of the editor may also be important. But most times the author usually is the editor, like myself, so I can as well still put my name on this. But for you, you can use your name, you can use anything you want. Then the creation date is usually entered automatically with the system time. This is the date of when the model was first written or created. Then last modification is usually the date when the proforma was mostly recently revised. This value is set automatically but can be altered. Then next we want to see model type. Alright, below are a row of radio buttons for entering model type. Detailed models would include the multi-zone building model, type 56. Simplified models would include such things as curve fit readers or the forcing function component. And empirical would include, like in engineering, you have design calculations, and then conventional might just be anyone. But however, what you choose here may not really matter. Most times it's just best to stick with the default. But where you really want to be thorough or very specific and you want to say conventional, just like normal CPC, then you can go for conventional. And below we have validation. Below this is a row of, here is a row of checkboxes to determine the type of validation that was performed on this model or will be performed on this model. This can be qualitative, numerical, analytical, experimental, and in assembly, meaning that it was or will be verified as part of a larger system which will be verified. So your component might be just a component of a larger system of components. So in assembly means it's going to be among other components, experimental, numerical, analytical. However, like I said, it's always best to stick with default if you're not sure what to do here. So for now, the default value is usually simplified and qualitative. And then below here we have icon. The icon that is associated with a model. For example, CPC, we know mechanical concentrators. We can as well look for a picture that looks like a CPC for this icon, or an image, so that anybody seeing the image will also know that this is a CPC. And usually this is the image that appears on your project window. Without this image, your proforma or your model cannot be used Trnsys. So it is very, very important that you must have selected an image different from any other person's image here on Trnsys. Clicking the icon will open the icon editor, which is Microsoft Paint or default, indicating that allowing you to select an icon for your model. If this function does not operate correctly, you can reinstall your Trnsys Studio. And the user also has the preference or the privilege to modify the picture or replace it with another picture in Simulation Studio. Just any picture cannot be used in this Trnsys except that with a .bmp extension, meaning bitmap. So if such a bitmap is not present in the Trnsys directory, the user can as well try to find this bitmap. Let's try to fix an icon for my CPC model here. I can as well click here twice or come here. It takes me to the Paint program. But what I want to do is I already have the bitmap picture on my computer, so I come here to choose icon. Be careful when selecting an icon for your model, because once you click, it brings you to the root directory of your Trnsys, where you have other icons for other components already designed and installed. Selecting any of this icon automatically affects the present design, because it tries to take on or inherit the character of the model that has already been designed with this icon. So it is always best to design yours. So we'll go straight to my computer, where I already have pictures to use for my project. So we go straight here to the download folder, and in the download folder we alright, let's continue. On my dialog window, this is a picture that I have already downloaded and saved for CPC. You can see the extension here, bitmapfiles.bmp extension. So I decided to name this DGD. You can name it whatever you like. CPC image, and then you open. Once you do that, Trnsys will automatically load the picture to this icon. Okay, that didn't do. Let's try it again. Choose icon. We go to PC, download, and go to this, and there it is, my CPC icon. And then for keyword, the lower right corner of the general tab has a box for adding keywords concerning this model, such as solar collector, building load, etc. So add a keyword here. You come down here and click on this drop down arrow, and we go to solar collector, for example, because that's what the CPC is, and we add maybe receiver or whatever relates to our project. We can add okay, I don't see anything. We can just leave it at solar collector. And then most importantly is the type number. If your Trnsys model has no type, then it cannot even be programmed or used in the simulation. Two edit boxes in this part of Proforma determine the type number for the component, as well as the number of possible instances of the component. Some components, such as the form, have an unlimited number of possible instances, as in number it can run. Other components, such as the multi-zone building, will only allow for one instance. Like for the CPC, we can even allow for one instance. But if you need to vary this to run for more than one instance, you can do that within the simulation window at runtime. Alright, we're going to call our type here type 152. You just type in only the number and not TYP, just the number. And after having done this, we can now go over to the description tab. Description tab, this is to describe the model. Let's say this is CPC. I can say this is a compound parabolic concentrator. This is a compound parabolic concentrator. It has an area of 0.25 and intended to generate a temperature of, let's say, about 180 to 200 degree Kelvin, degrees Celsius. Okay, whatever you describe your component to be doesn't follow any specific rule, but based on your discretion and based on your discretion of your model, then the comment deck, the text entered here will appear as a comment in the Trnsys input file. This allows to attach important information about the component. to all its users, including users who prefer to edit the input file with a text editor. This text should be short to avoid overloading the input file. Alright, here we decided to say not more than 200 degrees Celsius for those who are looking to have higher values from their CPC, or less. Then let's just put this to see how it works in the simulation. And lastly, the plugin part, which contains a path to an external application which will be executed to modify component properties. Instead of the classical properties window, such plugins can be developed by the user as described in the annex. Like for example, you want to use a Microsoft Word or MATLAB or text notepad editor to edit or modify some component properties of this model. You can write the path directory of such program here, so that whenever you want to do the modification, Trnsys will automatically call up that software or third-party software for you to be able to do that modification. But it is best to limit this cumbersome impossibilities or difficulties of using this third-party software or attachment to just everything within Trnsys. So it is best to leave it as default, because Trnsys already has a program or a classical property window for you to do the editing or modification of these component properties. That's all for description. Now we go to the variables tab. The variables tab of the proforma file or model, as seen here, is composed of several sections of information. These sections of information contain the parameters, inputs, output, derivatives, and special casts required to complete the Trnsys specification of a component model. So first, we go straight to the variable button here, which says variable, parameter, input, output, derivative, and we click. Alright, clicking the variable button opens up an empty table which allows you to create and name variables which will hold on to the values that will run in your simulation. What I forgot to tell you from the beginning of how to create a component in Trnsys was you need to have a design calculation and formulas that will formulate whatsoever you have in mind to design before you can think about simulating it. For example, a CPC would usually have this equation: QR equals to A, or area of aperture, F, a condition, if a condition in the calculation to say whether the solar energy is good enough, and if that happens, 1, if it's not, 0. Then the incident beam radiation, cos theta, which is usually the angle, tau curve, tau CPC, alpha R plus. Alright, these nomenclatures, we all have them. And here you can see some of the nomenclatures already have values and some don't. And those that have values usually will be parameters because they are fixed, and those that don't have values are inputs because they are subject to change. Or you might want to fix the value during runtime or attach them to another component within Trnsys which will automatically generate values that will run these ones. So however, this is the equation, and we're going to model this to fit. We're going to model this based on all these nomenclatures and their values that we have here, then to generate the energy at the receiver. What you need to note about this equation is that the QR on my left is the output value which will hold the answer or the product from all of these inputs or parameters on my right hand side. So in order to enter these variables within the Trnsys window, we need to create a table, and I'll do so right away. First, you need to come here and click add. First, you might want to add the QR. Since this row is still highlighted, you click on modify, and you come here and name this QR, which you might decide to leave this by default, or maybe the name of this QR is energy at the receiver, while this SN might be simple. Just leave it at default, it doesn't really matter. And then it's supposed to be an output value. Remember, in the equation, QR is an output, while area of aperture and the rest are inputs and parameters. So we leave this as output, and then real values. Let me talk a little bit about this. Boolean in programming is a type of variable. True or false, yes or no. Integer is a number, whole number. Real is also a number. Strings are text, or words, however. And our output is supposed to be either an integer or real, so we leave it at real by default. We know that energy is not dimensionless, so we can come here and look for the dimension for energy. I'm sure it's somewhere around here in Trnsys. Here, that's energy. Once you select energy, it's going to ask you either in joule or kilojoule, depending on the units you want to use. You can select kilojoule. Then the minimum, maximum values. Yeah, for the maximum and input, minimum values and default values for the variable. These values will be used when the component model is placed into an assembly. The default value must be between the minimum value and the maximum value. The default value is replaced by the initial value for the input, and derivatives are suppressed for the output. These values must be given in the unit specified between the minimum value and maximum values. This setting also determines if the minimum and maximum are included or not in the range. Sometimes this is not absolutely necessary, except you have values that are varying or not constant. It is always best to leave it at default and just enter a value as your default value if you have one, or simply leave it at 0 if it's subject to change at runtime. So we have seen the role of value as output, the type, the dimension, the unit, and then the description. You can decide to say energy of the CPC at the receiver, and we OK. Alright, let's go ahead and create other components. I can say add and modify. Here I can say capital A, AP, area of aperture. Of course, remember we have it as input, and the value is 0.25 meters square per CPC. So it's an input value, or let's call it parameter, because we don't expect it to change from 0.25. It's a real value. And the dimension, area, so we select area, and we have meter squared or centimeter squared, however we want to use meter squared. The default value will be 0.25, and we can decide to describe it as area of aperture, and OK. Next we have to define F. We can add and modify, and we call this F, and then we have it as input because it is subject to change. It's a real value. It's dimensionless, so it has no unit. It can either be 0 or 1 based on the conditions we stated here earlier. So we leave this as 0, and we can decide to call this conditional, and OK. Alright, let's say we have all other parameters described here created. We can now OK, and we come back here to the default window of the variables. We have what is called special card. Once the user has defined the parameters, input, outputs, and derivatives, some components require additional description statements or cards. An example of a model that requires a special card is type 65, an online plotter, which must specify the titles for each axis, the y and x axis, during the plots. This special card can be inserted into the Trnsys input file by the use of the special cards section, which is also accessed through the variable tab of the proforma. An example of the use of special card section can be seen or will be seen in the plotter when we start to use our newly created model within the assembly panel window. Then for comments for each unit written in input file, it is now possible in Simulation Studio to have a comment written to the input file from each component. These comments will be entered for each instance of the component. A box is placed in the proforma at the bottom of the variables tab to allow the model developer to enter a default value for this component. Alright, next we go to the Files tab. The Files tab the Files tab is the final tab, which contains information about all the files associated with the component. This includes external files such as data or output files, which are associated to one or more parameters of the component, like the source code, in which may be exported as Fortran. We'll soon get there soon, or C++. The whole essence of this window is to allow the user to associate a Trnsys parameter with external programs or files, allowing external programs to feature within Trnsys, and calling up, like when we want to create or program this model based on our equation written here and the values entered in the parameter input window, then we will really understand how this files window actually works in Trnsys. So finally, there is a box at the bottom of this window called Associated Files right here. This box contains a list of related files and internet links for this component. That is, if you have. These files can then be opened in the appropriate program by selecting their name and pushing the edit button on the right. Let me give you a very good example. For example, you don't want to open the output from this component within Trnsys plotter. You can open it within Microsoft Excel by indicating or associating it within this associated file. And then you can also use Microsoft Word, which must of course be installed on your computer and be accessible for you to also generate or edit results based on this component. So on this note, I think that we have actually touched nearly all the areas for the new model. So let's go ahead and create. Alright, now we have created a new component, and you can see the name of this new component is still called component 1 because we have not saved it, and it doesn't yet appear here on the direct access or directory window. So we'll go to save, either save here or save through file, either one, but we have not saved initially. So once you click save, it will open a dialog window where we have to trace our Trnsys 16 Studio. You don't just save it anywhere but within Trnsys, where the program can find it and call it up during runtime. We go to Trnsys 16.1 and we open Studio and go to Proformas. All newly created models are saved within categories, either application library or controller electrical, depending on what the model is about. So we know in Trnsys we have solar thermal collectors. This is the folder right here. You open it, and we have a CPC collector folder. We have another CPC collector folder. So depending on what CPC, whether it's flat plate or evacuated or parabolic, however, this is our CPC. We're going to just call this type 152 without a space, and you can save your CPC within the into the general CPC folder, which with Trnsys is 74. You can save yours in here, or simply create a new folder here. Yeah, and then you give it a name, maybe type 154, or you simply call it CPC collector, and then save this file into it. And so once that folder has been created, we open and then we save our new component by clicking save. And once that is done, Trnsys saves the new component into the folder. You can see the name now changes to type 152, and it doesn't yet appear here, okay, until we restart Trnsys, or we simply close this and try to start up a project within Trnsys. So I'll close this and come to new, empty Trnsys project, create, and once this window pops up, you can see what's called direct access. You refresh tree, which refreshes this window on the right, and then you see that your new component will appear under solar thermal connectors, as you can see it here, type 152. So you can drag or click this and click into Trnsys. You can see the type has been created. So this is all about creating new types in Trnsys. But for now, that is not the end. This cannot run. Something still has to be done. And lastly, I need to show you what must be done, and then we'll continue from the part 2 of this video. So for now, if this cannot run, if you want to try that, you can either right click and run simulation. You can right click and run simulation. You'll see that this component will not run. It says 2 errors were found in the deck, check the listing. That's because this component has not yet been programmed with the formulas that we have here and with all these parameters just yet, so it will not run. Now let's close this window. Save changes to project 19. We say no. By default, every project you open in Trnsys starts from 1 and continues to number as you go. So for now, we have created a component and it appears here on the direct access tree or Proforma direct access window. Now, to call back these components we have created, we collapse the tree and simply click on this twice to call back the Proforma. This is the component. Now the last thing we need to do is to export this file for programming with the formula which we have written down. But before you do that, you go to File, you go to Settings, and you go to Directories. Here in Directories, Fortran Environment, C++ environment. But we're concerned with Fortran environment because Fortran is very good for formula for translating code and formulas. That's why it's called Fortran. Simply stands for formula translation. So here I use code block, but we both know from the beginning the requirements for creating a new component to work within Trnsys, which is under the programmer's guide. You need Intel Visual Fortran and Visual Basic. You install Intel Visual Fortran into Visual Basic and you call up the path here, you know, C program files, Intel Visual Fortran, whatever it is, .exe, so that whenever you want to export this file, it will call up Intel Visual Fortran, from which you edit the Fortran code and create a new component. So for now, I have code block here, so I'm going to show you how this works. So now I need to export this file for programming. I come to File, we go to Export as Fortran, and here we have to go to the source code, the folder within Trnsys called source code, where all the source codes are stored regarding every component. I already have mine here, type 152, but to learn how to save it, just like before, you can create a new folder and call this type 152 and simply save. okay, and simply save your type 152 into it, and that will be all. And then Trnsys Studio says Trnsys Studio has created a source code template for your new type in blah 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 path, as well as project workspace. When you press OK button, Trnsys Studio will attempt to open the compile project in your Fortran compiler. And my Fortran compiler, remember, is code block. After completing source code, the build function in your compiler should directly create the drop-in DLL. You know, this drop-in DLL is very important. Without it, the component cannot run. If the project does not open in your compile environment, please check the installation of your Fortran compiler. That means if you do not have Intel Visual Fortran, which only can create a DLL, you may not be able to actually create the DLL, but your program will either be open in Intel Visual Fortran or nothing at all. So I'm going to click OK. So when I click OK, Trnsys attempts to open the newly created source code in code block. Is either you can write your Fortran program from the beginning all by yourself, or you allow Trnsys to write the skeleton code for you, on which you're actually going to write the formula and the remainder of the code to be used in Trnsys. Alright, this is my code block compiler open, in code block integrated development environment open, and then compiler selection. You can see code block has many other compilers installed within it, but we are concerned with G95 Fortran compiler, which is a bit compatible with Trnsys. The rest are not, and we OK. And then you can ignore this or just deselect or OK. However, it will open up the project for you, or you simply say select file and you select this. At this point, I'm going to collapse the screen so you see what's going on here. Our code block environment is open right before us, and you can see it has created a type 152 subroutine. You can see the name of the author, the date, the name of the object CPC model. You can see the comment we put there, not more than 200 degrees Celsius, and you can see the inputs that are declared, parameters. Alright, you simply place our equation here, which translates to QR here as the output for this equation. After having done this, you build the program and run, and then look at the window here to see what the error will be, and it says C user cannot source code type this, that, okay, fatal error, can't open module, and that. So from this point you can actually debug this code until you get it right, and then as you continue to build, it will build for you a .dll file into Trnsys, which allows your new component to be run. Thank you very much for watching, and watch out for the part 2 of this program on Programmer's Guide, where I'll show you how to use Intel Visual Fortran to actually configure or program this newly created component to run within Trnsys. And if you like my videos, you can